IDEX Corporation is a Chicago-based fluidics company. We are a $2 billion company that provide engineered solutions to customers worldwide in niche market applications.
IDEX is a global fluidics leader serving high-growth specialized markets. We are best known for our expertise in highly engineered fluidic systems and components. Our products touch lives every day. Whether it's a life-saving rescue operation, dispensing fresh juice to a first grader, or fueling aircraft, IDEX is a leader in creating enabling technology. Headquartered in Lake Forest, Illinois, USA, IDEX was founded in 1987 and stands for Innovation, Diversity and Excellence. The company trades under the symbol IEX on the New York Stock Exchange and the Chicago Stock Exchange. IDEX Core Values. Our core values unite our teams around the world by setting the standards for behavior.
At IDEX, we design, manufacture and distribute some of the most recognized brands in the positive displacement, pump technology, fluid metering, specialty compressors and fluid handling systems.
This group is focused on 4 key market segments.
We address customer needs in the movement and measurement of process-critical fluids and gases in niche market segments. Our key segments include oil and gas, chemical, petrochemical, specialty chemicals, food, pharmaceutical, and water treatment.
This is IDEX India facility in Savli, Vadodara. We set this facility in 2011. We recognize that our customers in India want the best products anywhere available in the world. And so we set up this world-class facility. Here we are currently manufacturing products for 6 different businesses.
Savli, Vadodara in India. The facility incorporates a highly effective team-oriented environment that integrates manufacturing, administration, and the industry's latest computerized technology. It also includes a state-of-the-art calibration and testing facility that meets custody transfer norms as per weights and measures. The Kanban replenishment system is implemented in operations to meet customers' lead time expectation for run-up pumps and spares. Model-wise Kanban supermarkets have been established to store parts. Based on real-time demand and consumption in production, Kanban signal cards are released to the purchase department for order replenishment. We have a state-of-the-art assembly workstation made of aluminium square profile. All assembly stations are equipped with pneumatic tools and the required fixtures at the point of need. Workstations are ergonomically designed to provide the highest level of safety for the product and the associates. A high level of 5S culture has been cultivated in operations. All pumps are tested on the hydrostatic test bench to ensure no leakage from any part. All metallic pumps are tested at 125 psi pressure and non-metallic pumps are tested at 100 psi. We have robust packing methods in place to avoid any in-transit damage to our product. To provide extra safety to our product, each carton is packed and wrapped on a wooden pallet before dispatch. Liquid controls. In the year 1954, Fred G. Wacker Jr., envisioning the idea for liquid controls, acquired the patent rights of George Richards' 3-rotor principle. Liquid controls PD meter. The liquid control's metering principle. A liquid control's positive displacement flow meter is, in a sense, a hydraulic motor with high volumetric efficiency that absorbs a small amount of energy from the flowing stream. This energy is used to overcome internal friction in driving the meter and its accessories. With all other conditions being constant, the LC meter does not vary more than 0.02% in repeatability over the entire range of the flow. The LCPD meter is bidirectional and accuracy remains unchanged in either direction. The meter has a most ideal combination of minimum seal or slippage area with low pressure differential across this seal. This results in superior accuracy over a wide range of flow. The measuring chamber walls only sense the delta pressure across the meter inlet and outlet, which allows for thinner chamber walls with less distortion. System piping stresses that are absorbed in the external housing are not transmitted to the precision measuring element. Liquid control's air eliminator. Eliminating the free air or vapor. The product is pumped through the system and enters the air eliminator. If free air or vapor is present, the pumping system moves the free air into the air eliminator. Once in the air eliminator, the air rises and vents from the center vent ports. As the product enters, it displaces the air, allowing the float to rise. As the float rises, the two reeds cover the vent ports. This stops the venting of air and prevents any product from leaking out through the vent ports. If free air enters the system, it will rise and displace the liquid. As the liquid level drops, so will the float. As the float drops, the two reeds are drawn away from the center vent port and free air vents from the system. This cycle is repeated anytime free air enters the metering system. Energizing the NO solenoid locks fluid in the valve cover, which locks the valve in a fixed position to maintain a constant flow rate. Whenever a change in flow rate takes place, the flow controller signals the appropriate solenoid to open momentarily to readjust the flow rate to its set value. A Y-type strainer is provided at the inlet side of the tubing to filter the solid dust and particles, preventing them from entering the diaphragm chamber. Needle valves are provided for fine-tuning the flow rate. Air Eliminator Installation. Look for the arrow marking for proper flow direction. The vent of the air eliminator should be at atmospheric pressure. The vent is provided with a ball valve. The ball valve is to be kept in the open condition all the time, except in the event of any leakage. Air Eliminator Commissioning. Close the manual valves located at the outlet and inlet of the air eliminator. Start the pump. Open the inlet valve slowly and allow the air to bleed through the vent. Once air stops coming from the vent, open the outlet valve. If care is not taken, a sudden rush of liquid may cause damage to the float. During initial operation, due to the mixture of air and liquid, some product will come out from the vent. This is not leakage.